We now move on to our next presentation. It is an honor to have with us Mr. Anuj George with us today to give presentation on embracing digital innovation in garment manufacturing, an Indian case study. Mr. Anuj George is Chief Business Officer at Solve I8. His 15 years tenure has been dedicated to driving the future apparel manufacturing through the fusion of core manufacturing principles and advanced technology. Mr. Anuj's keen focus on consumer trends and visionary approach have propelled cutting-edge initiatives that integrate industrial engineering concepts with technology, positioning him at the forefront of Industry 4.0. His leadership not only fosters robust collaboration across Southeast Asia, but also ensures that apparel manufacturing and technology evolve seamlessly together. Mr. Anuj, you are invited to share your knowledge on digital innovations.
That it's not boring, and that's why we're invited again. But yeah, thank you so much for this opportunity. Quickly introducing myself to everyone who does not know me, and some of the known faces I definitely recognize. I'm Anuj. I head a company called Solve. I8 is supposed to be it. Frequently not pronounced right, but yeah, like I'll introduce it to everyone. It is called Solve. We basically try to make simpler products for complex processes, something that everyone can use at any given point of time and does not have to customize that frequently to adapt into their own manufacturing setups is what we try to do. We are right now present in approximately 7 countries. India, Pakistan, Bangladesh, Vietnam, Indonesia, Korea now, and Pakistan as well. We are working with about 125 manufacturing factories across these 7 countries. These 125 manufacturers produce approximately 20 million garments a month, and approximately 4,000 users use our product on a day-to-day basis. Interestingly, we know that we are 90 minutes after lunch, and usually 90 minutes is the duration when human mind stops grasping or understanding things. So I'll keep it snappy, I'll keep it informative, I'll keep it with, let's say, very factual presentation. The last 2 sessions, I would want to maybe touch upon them slightly because it is interesting to see how things are evolved over the last, let's say, 3 to 4 years. So in 2021, we spoke about how mechanics, or what are the different mechanics of a future-ready apparel manufacturing. We spoke about what are the different pillars. You need to have connected technology, you need to have intelligent systems. All of those facts is what we talk about and we spoke about in 2021. In 2022, we moved forward and we said that how do we basically use data analytics to help manufacturing excellence. Those are the 2 topics that we spoke about earlier before coming here. So now, in let's say the last 4 years when we started, the Indian government had a very interesting aim at that point of time that manufacturing needs to help create about 25% of jobs by 2025. And the second aim that Indian government at that point of time had was to, I'm sorry, the text might not be visible, but yeah, that manufacturing needs to contribute about 25% of the GDP of India by 2026, FY 2026. Now this is very interesting because we have been trying to adopt technology to grow manufacturing GDP of the country, and that has been evident. We have seen an uptick in terms of the adoption of technology and the spend that we have done in adoption of technology. But has it been enough? No, it's not been enough because the competing the countries which are there, which is, let's say, if we talk about the leaders in adoption of Industry 4.0, which is US and Germany, where we are seeing a lot of nearshoring happening, where the shoe manufacturing is shifting very heavily to Germany, where now manufacturing is also shifting to Germany, apparel manufacturing is also shifting to Germany. There, they have spent about 4% of what their manufacturing output is in technology. Similarly, if you look at, let's say, China and Vietnam, they are not, let's say, the leaders in Industry 4.0, but definitely, let's say, few of the leading countries who are able to use it or investing heavily into that. India, in terms of discrete manufacturers, and I'm specifying discrete manufacturers here because there are two types of manufacturers, discrete and process. Process is like pharmaceuticals and everything. Discrete is wherever you have automobiles, apparel manufacturing and textiles also fall into discrete. India has spent about 3% of their manufacturing output. But when we talk about textile manufacturers, and in this we take into account textile and apparel both, not only the apparel manufacturers, but textile and apparel manufacturers both. We have spent only about 1% of our manufacturing output into tech. So while there has been an uptick and we definitely see more adoption happening day in and day out, but the scale with which the competition is doing or the other countries are evolving is much, much bigger or almost double of what we are trying to do at this point of time. So that is the first piece that I wanted to maybe quickly talk about. The second piece that I wanted to talk about is that where did we invest this money? The majority of the money that we invested went into data and analytics, and which is what every one of you would also realize, that we invested into MES systems, we invested into cloud ERPs. Anupam is here. A lot of manufacturers started talking about cloud ERPs. Earlier it was all on-prem ERP solutions that we used to use. Now people have started moving into cloud, people have started looking at data, people have started looking into analytics. So that is where the maximum amount of investment happened for the textile manufacturers in India, where we looked at investing into data and analytics. The second level of investment which happened, 25% of the $1 billion that we spent in technology went into more of connectivity tech, which is we invested into 5G, we invested into more of IoT-based sensor technology, which helped you to connect directly and take data. Now this investment primarily at this point of time is more towards the textile side rather than the apparel side, because unfortunately the sensor technology for apparel manufacturers is not at a matured stage at this point of time. But for textile manufacturers, we have solutions which can help them to get data directly from the machines and evaluate it. 8% of the money that we spent was more on the intelligent automation, which is using RPA to basically create POs in the ERP, because it is a humongous amount of task. Quite a few people would agree that to create a PO in an ERP takes a great amount of work. But Indian manufacturers have not invested that heavily. But if you basically start to look at, let's say, a little bit south of us, Sri Lanka, little bit east of us, Vietnam, people have started investing into RPA to help them automate these tasks as well. So it is not only automation of your factory flows, but it is also automation of the other processes, which can help you to de-skill the employees that are there and use them in the majority of the work, which is, let's say, giving inputs to the management. And the last piece is where we 2% of the spend was more on the advanced digitech. Now, when I say advanced digitech, it basically means digital twins, more from additive manufacturing, dark factories. That is where we spent it. So this, if you look at this breakup, that's where you will also see that when you look at the deployment types and everything, that's where you'll be able to see that the maturement of the technology also happens in that same space. So when we look at the mature technologies which are available at this point of time, you have cloud computing, which is matured. You have IoT, which is mature, you have AI in manufacturing, which is mature, and you have 3D printing, which is mature. So that is the reason where we have invested heavily into these solutions, or we have validated this across, and we have said that, okay, fine, this works, so definitely let's implement it into our factories. The second piece, which is, let's say, the second level of maturing technologies, which is something that you should be thinking right now to implement, is, as I said, RPA, robotic process on that, predictive planning, quantum computing, and cyber physical systems. Sound very big, very simple, not difficult. RPA is basically, imagine something basically which can do all the data entry, read a tech pack, and enter it into an ERP. Does not need a merchandiser to do it. Reads a tech pack, creates the BOM automatically. So something on that front. So RPA is that. Predictive planning, you have a bunch of data, you have humongous amount of data. Can we start looking at, let's say, all the data and start to plan the systems and plan the lines much in advance in more, let's say, realistic manner? is what we look to do. Quantum computing is, let's say, slightly lesser piece, but let's say cyber physical systems is something where we need to evolve more on the sensor technology, and we have companies which are trying to do that at this point of time, is where at this point of time the manufacturers now need to focus on, because that is where the next piece of jump or cost saving for you or improvement in the manufacturing facility for you will come from. Expanding technologies, which is, let's say, something that is, let's say, 5 years away, which is AR and VR in manufacturing. And this is, I'm speaking specifically from a parallel manufacturing standpoint. We need more innovation, and we need more research to help us use AR and VR in manufacturing. It is being used in automobile manufacturing at this point of time, but it is still away. Wearable and sensors is what we need to, which is still evolving. And the last piece is the cyber security technologies, which are, let's say, something that we should look beyond, let's say, 5 years to invest in. The last piece, which needs to start, let's say, which will start seeing precedence in, let's say, 10 years time, is more from a digital twin and voice control devices. I know a few factories which have been trying to create voice control devices to help them take decisions. But when you look at all of these things have a foundation to it. Where if you, let's say, want to create a digital twin, let's say 10 years from now, where you are able to, or 5 years from now, where you are able to put an order into the system and able to look at the entire visualization of it, you will need the data set for it. You need all the control variables mapped into the system for it. So without the foundation for creating a digital twin, we will not be able to reach to that particular level. And which basically for them to help plan it better the next time, which is where the problem lies at this point of time. And it is basically a lack of not having the right tools on the factory floor which help you to do it. Because what is happening is that the data flow is flowing in a linear fashion, and unfortunate piece is that it happens maybe slightly late. And I'm not saying very late, slightly late. And that slightly late is maybe after 2 hours or at the end of the day. What we really need is that you need to make enterprise decisions on the floor, every single person on the factory floor, including your middle management, including your top management, with the help of real-time solutions which are enabling your shop floor, which help you to tell you what is the prediction going to happen based on the real-time data, and help you to decide what needs to be done next. You need suggestions on the fly, and based on the suggestions, you take a decision, or the management takes a decision, and automate as many processes as possible to ensure that we are able to control what is redundant automatically and does not require a management person to involve or spend that amount of time in that particular process. And that is where the biggest improvement lies, where we start changing our decision flows from more of a traditional approach or a linear approach to the on the spot. And for this, you definitely need more of the maturing technologies and the expiring technologies to be adopted into the factory floor to ensure that you are able to drive this particular change. What are the few examples based on, let's say, the different technologies that we spoke about, and how can you maybe create those changes in the factory floor is what we would want to now discuss. The first piece is upstream. With the suppliers, how can you maybe work at this point of time? Is it possible? And this is a very, very live example. We have been working with, let's say, Vietnamese manufacturers, and we have been working with Indonesian manufacturers and now Korean manufacturers, where their POs keep changing till the last delivery date. Their POs are not confirmed till the last particular date, where the POs can continuously split into multiple destinations and multiple pieces. Now, this is basically the brands becoming smarter and keeping it as close to their selling date as much possible. While this is happening, now imagine if we had to do it, all of these processes live with all of these changes in a system. The moment you get a PO, the first thing that the merchandisers do, or the pre-production activities that we do, is that we look at it, analyze the POs, we enter it, we create a BOM, we create the consumptions, and we basically start creating the orders. if we had to get into the same nimbleness of let's say the brands, it will be really difficult for us to continue to do it. Over the last 4 years, the number of styles being manufactured for the same capacity that you are manufacturing. So let's say if you are producing 10,000 pieces 4 years back, and you were producing those 10,000 pieces for 20 styles, now the same 10,000 pieces that you are manufacturing for 40 styles. So the number of styles that you are manufacturing has gone up even though your capacity has not. So the complexity that you are dealing with on the manufacturing floor, that your teams are dealing with, has gone up considerably. This is one. The second piece that has impacted further is the lead times. Earlier we were working with longer lead times. So what was happening is that we had 120, 160, 90-day timelines. Now it's more 30, 60 day kind of timelines, which is almost half of what we were earlier working with. So if you look at twice the number of styles and twice the number of reduced timeline, the amount of effort or the complexity that is there for the manufacturer has quadrupled. And that is what you're dealing with. And that is where we, in the upstream side, we need real-time order management. So imagine something, let's say the moment you get a tech pack, you need a system which is able to read the tech pack, create the bombs, create the POs, send it out to the supplier. You do not need a human intervention in that. You need something to be automated in that entire process. You need to understand when you are getting the order that if I'm getting for, let's say, a specific fabric type A, how has my supplier performed in the past? Based on that, should I place the order with supplier A, supplier B, supplier C? Those are the types of technologies that you need to look at when you're looking at, let's say, the upstream side of the execution. At the planning side, and this is where the second point comes in, and when Ms. Randhawa was speaking about pre-production activities, there was one very critical point, which was that it is very important to ensure that the pre-production activities are met. Because what usually happens is, and you can check this at your end as well, over the last 6 months, because we have launched a product called Planet, and which is a planning tool, we started working with manufacturers and started gathering data. We looked at, and the astonishing figure that we came out to is 80% of the orders are usually delayed even before they hit the shop floor. And majorly it is basically because of the pre-production activities being delayed here and there. If we need to basically ensure that we are able to do better job at that, we need to ensure that we are able to do a predictive demand planning based on that block capacities. Second thing that we need to look at is real-time replanning and scheduling. Gone are the days where you could have a tool where the planner needs to drag and drop a particular strip onto the system. On the planning tool, you need a button which can say replan, and automatically based on your today's output and based on the efficiencies of the line, the entire board gets replanned. That is what we are looking at, or what we should be looking at for the planning side. Based on let's say more from the, let's say, execution of certain orders, we need to create decision models where the planners do not need to do the redundant work. Planners do not need to go and update the output into the system. Planners do not need to go and plan orders into the system. They need to look at, okay, fine, if I do A, then the output will be this. If I do B, then the output will be this. Based on that, that is what we need to start executing more from a planning perspective. The third piece, what we need to look at more from production, and it is interesting for me to say, because most of the manufacturers in OGTC have definitely been at the forefront of adopting solutions, and a lot of the production level work is something that we have already tried to do. So what we need to get more into is more of predictive maintenance. We need to get more into self-optimizing lines. We need to get into prescriptive scheduling. Very interesting word. If someone does not know what prescriptive scheduling means, we will talk after the session. Assistive operations and traceability. What we mean by assistive operations is that if, let's say, there is an operator and he is working on the style for the first time, then there should be something which helps him on the job to get trained. What is predictive maintenance? Based on the maintenance records, the mechanics need to get a notification that my mean time between failures for a certain machine has been 21 days. And it is 21 days since the last impact or let's say a downtime on a certain machine. You need to go back to that machine and maybe maintain it once again. So that is what we need to try and do in the production scenarios. Downstream, and this is where a lot of manufacturers outside of India are excelling at it, where they have started working along with customers and partners to integrate their decision making with the brands, where they have started working to integrate their data centers with the brands, where the decision making is collaborative and not one way. The second part, which is interesting, and the DPP might be one of the pieces which can help out, is the real-time location data. Where is it exactly at this point of time? If we are able to use a tracking technology in every garment, which basically helps you to track the garment within the factory floor and going beyond the factory floor, be it an QR code or an RFID, is something that is definitely something that can help out the manufacturers. And the last piece is micro-fulfillment is something that a lot of manufacturers based out of Bangladesh and a lot of manufacturers based out of Vietnam are now doing, where they usually get a long set of orders, about let's say 10 million pieces, but they take the responsibility to ship out even one piece if the requirement is there. And that micro-fulfillment goes on because the earlier echelons of their supply chain are nimble enough, that their planning is nimble enough to take care of those orders. Their production is nimble enough to shift and manage that vendor managed inventory type of a model. And they have those relationships with the brands which basically help them to do it. So that is my thoughts, what we feel that we can improve. Very specific, very few suggestions which I feel can help out manufacturers at this point of time. And yeah, we try to help out manufacturers with the help of solutions which is more from a factory OS perspective. What we try and do in the factory OS piece is to try and include everything which is there on the shop floor within one single system, including the planning, tracking and maintenance of your factories, so that the planner is actually able to replan the entire board for the week without having to manually drag and drop each and every strip. He can do it with the press of one single button. So yeah, that's my time. But thank you so much for being a lovely audience. Happy to take any questions if there are.
Because we are living in the digitized world only, And one frame where you said in one slide, you said that Government of India has given a clarion call that by 2030, we tend to achieve, I think, 450 billion to make this textile economy to grow to that level, Around 100 billion they wish to achieve out of that through exports only, And I think Mr. Giriraj Singh, he said 5 days ago only at Textile India Curtain Raiser, around 3 crore ka hum create karenge jobs, which is great, But given that the backdrop of redefining of roles and responsibility in the AI-driven, digitized-driven world, de-skilling also is becoming a buzzword. Do you think that there is a doability? Thank you.
Thank you so much. Yes, it is doable. It is not something that is not possible at this point of time. The only thing is, and this is where the difference lies. The difference between Indian manufacturers and I'm sorry, I'd like to be self-criticizing as much as possible because that is the only way to improve. The difference between, let's say, an Indian manufacturer and a manufacturer outside is how they adopt technology is something that is very critical. That is where we need to decide how to basically go forward. Usually what happens when we go outside of India and when we work with these manufacturers is that there is a very clear-cut, goal-oriented POC that we do, which is called a proof of concept, where we go and sit with the manufacturer and say that, hey, listen, we need to do this within the next 3 months, and this is what we are going to achieve. And there is a dedicated team from both the sides which basically help us to achieve that. Once that goal-oriented process POC is completed, the immediate next step is to scale it up to at least one factory or one particular cluster. The moment they see this, the execution into the next steps is very fast. So in in this entire piece, the key lies in ensuring that the doability of whatever you want to adopt, be it let's say AI, be it generative AI, be it let's say predictive, voice control devices, it is to identify a partner, get into let's say the goal-oriented POCs and test it out. And yes, there will be failures. And this is where also, unfortunately, there's a difference between tech industry and the apparel manufacturing, where we like to fail a lot, where we try to develop everything at a fast because we have 2 week sprints. We develop something, we fail, we do it again. But in apparel manufacturer, you cannot fail because a lot of livelihoods are dependent. So you need to figure out a very smart way of doing a POC where you can do let's say multiple, fail at maybe 9 or 10, but those 1 or 2 things that you are able to excel at or able to let's say get value out will be able to pay for the remaining 10 POCs that did not work out. So that is how it is, let's say, something that we can break it down and do a doable technology in the manufacturer. And it requires the manufacturer also to take the leap of faith to start doing that. But yeah, thank you so much for that question.
Thank you, Mr. Anuj George, for an interesting presentation and focusing on empowering factories with advanced cloud solutions which can help in solving digitalization challenges. Automated planning, scheduling and tracking are key factors for embracing improvements in manufacturing. So now I would like to invite Mr. Arjun Uppal, Director PM Pro Exports, to kindly come on stage and present Memento to Mr. Anuj George.